So this will be the third and last lecture of module number 6. In this we will be seeing what are the different types of control systems that are used in automobiles. See, in the first lecture we saw alternative fuels. In the second lecture we saw what an engine control unit is and what are the sensors that are used in the engine control unit, right? But there are complete systems. As I told you, there can be several different control units inside a engine, inside one single vehicle, inside a single engine. Okay. So different engine control units are responsible for different functions. For example, one might be responsible for the throttle position. One might be responsible for the amount of fuel injected. One might be responsible for what is coming out of the exhaust gases. One might be responsible for the amount of exhaust gas recirculation. Thus, there are different engine control units and there are different functions. In this lecture, we will be seeing some of these functions which are included in your syllabus. Okay, so this is exactly what I was saying. See, today's automobiles integrate a large number of electronic sensors and actuators. And electronic systems have to control and optimize several different system functions. Some of these are spark control systems. So when exactly is the spark produced and what is the intensity of spark, what is the number of spark, what is the duration of spark. There can be air management system which manages how much amount of air is coming into the combustion chamber. When is the intake valve opening? When is the intake valve closing? When is the exhaust valve opening? When is it closing? Right? So there is an idle speed control system. See, from your module number 2, you should remember that when engine is idling, it requires a rich air-fuel mixture because the throttle valve is completely closed. So that is the idle speed control system. Even when the throttle is completely closed, sufficient amount of fuel should be sent to the engine so that the engine keeps on running at minimum speed. Then there can be exhaust gas recirculation system. As I have told you already, exhaust gas recirculation is used to control the amount of NOx produced inside the engine. Fuel injection system. What is the quantity of fuel injected? When is it injected? In what direction it is injected? What is the number of injections per stroke? That is fuel injection system. There is knock control system which is dependent on several different things. For example, if there is knocking, it will adjust the engine speed, it will adjust the amount of fuel intake, etc. Anti-lock braking system, to prevent the skidding of the vehicle, we use anti-lock braking system. There can be engine speed control system, which ensures that the engine is operating between a fixed engine speed so that we get maximum efficiency. This engine speed control system is also in a way kind of responsible for the automatic transmission systems. There can be cruise control system which controls some part of the steering of the vehicle. Because there are many different ECU systems that are being used nowadays. Out of all these systems, we will be seeing these first three because these first three are in your syllabus. Okay. So first of all is your electronic spark control system. See, as the name suggests, what are we going to do? We are going to control the spark. And how are we going to control the spark? Electronically. Right? So see, in an engine, the amount of power produced is directly proportional to the quality of the combustion. Better the combustion, more amount of power is produced. So the spark should be produced at the perfect amount of time so that the maximum amount of combustion takes place and maximum amount of power is developed by the engine. What happens as the engine speed changes, the time available for the combustion of the fuel goes on reducing. Hence, as the engine speed goes on increasing, the spark should be produced slightly earlier. This is what is meant by electronic spark control. So, electronic spark control controls when exactly the spark is produced. Not only that, in the modern engines, electronic spark control also controls how many times the spark is produced. Okay? Nowadays in some engines, there are multiple sparks produced. Why are multiple sparks produced? A small spark is produced initially so as to start the burning process. And then the main spark is produced so that large amount of fuel is burnt at that amount of time. Okay, you must have heard of GTSI engines, right? Dual twin spark ignition, right? So this is what is possible only by electronic control. This is not possible by our traditional mechanical control systems. Okay, so that is how the spark control system works. Basically, the spark control system has to control when the spark is produced, how many times the spark is produced, and what is the quality of the spark produced. So how does the spark control system basically work? See, the spark control system, like any other engine control system, works on three things. First, there are intake sensors. These intake sensors take information from various parameters of the vehicle. They collect this information and send it to the engine control unit. Okay, so this is your second part, the engine control unit. The engine control unit depends on these intake parameters and there is code written inside this. Okay, depending upon the information received and the code written inside this, it takes suitable action and sends signal to the actuators. So in our case, in our electronic spark control system, what are the inputs required? First of all, engine speed sensor is required. Why is engine speed sensor required? Because we must know at what speed the engine is operating. Is it at low speed or is it at high speed? If it is at high speed, then we have to produce the spark early. Crankshaft position sensor is required because we have to know when to produce the spark, right? When the piston is just about to reach the TDC, that at that time we have to produce the spark. That is why crankshaft position sensor is required. Intake air sensor is required because whenever, see, if it is a rich air fuel mixture, then the quality of spark produced can be low. But if it is a lean air fuel mixture, then the quality of spark produced should be very high. Otherwise, combustion will not take place. Hence, intake air sensor is used to determine what is the air fuel ratio. Okay. Engine temperature sensor is required. Why is engine temperature sensor required? Because if it is cold starting conditions, in that case the quality of spark should be higher and the time for which the spark is produced should also be higher. Why? When there is cold starting, there is possibility that combustion might not start. Hence, the spark should be produced for a longer amount of time to ensure that the combustion starts. And last is the throttle position sensor. Throttle position sensor is important because we can know whether the car is accelerating or idling, right? If it is idling, then the spark timing is different. If it is accelerating, then the spark timing is different. That is why all these sensors and many more collect the data, send it to the engine control unit. There is code written inside the engine control unit. Based on the code written inside the engine control unit sends signal to these actuators. What do these actuators control? They basically send a signal to your ignition system, right? It sends a signal to your ignition system. Now this ignition system can be of different types. It can be capacitive discharge ignition system, right, which is the most common system used right now. Or else it can be another type of electronically controlled system, right? So based on this, what are the things that we are controlling? We are controlling the spark timing, when exactly the spark is produced, spark duration, for how much time the spark is produced, and spark strength. What is the strength of the spark produced? Okay, so this is how an engine control unit works. So basically, if you are ever told to write a short note on electronic spark control system, you have to explain what are the different sensors that are necessary. You have to explain what it is exactly controlling, and you have to explain why it is necessary to control the things that it is controlling. Okay, so this is all written over here. After this, the next system that we will be seeing will be the idle speed control system. See, in this diagram everything is explained very well. Okay, this is a very good diagram that I found. Okay, made by this person. See what is happening. See, this is your intake manifold. This is your intake manifold. From here fresh charge is coming. Fresh charge, this is from atmosphere, fresh charge is coming, and it will be going into your intake manifold over here, and from here to the various engine cylinders, right? What happens during idling? Your foot is not on the throttle, not on the accelerator pedal, because the accelerator pedal is completely up. Because of that, the throttle plate is also completely closed. Now if the throttle plate is completely closed, no amount of air will able to go into the engine cylinder. If no air goes into the engine cylinder, there will be no fuel going into the engine cylinder, right? Some amount of air will go from the corners. Okay, some amount of air will go from the corners, but the air going into the engine is not sufficient to carry the required amount of fuel, right? That is why we have this control system. Okay, see over here, what are the sensors that are sending information to the idle speed control system? It is the engine coolant temperature sensor ambient air temperature sensor, manifold pressure sensor, and mass airflow sensor. These sensors are sending the information to the ECU. They have written over here ECM, that is the same as ECM, engine control module. Okay, so they are sending the information to the engine control module, and the engine control module is sending the information, sending the signal to this actuator. What is this actuator controlling? See, this actuator is controlling how much this spindle is moving forward and backward. Okay, how much this spindle is moving forward and backward. See, if the spindle is completely forward, this will be completely closed and no air will go from here. No air will go from here. But if the ECU sends the signal that the amount of air going to the engine is very less, it is possible that the engine might stop working because the engine is not receiving sufficient air and fuel. It will send signal to the spindle and the spindle will move backwards. As the spindle moves backwards, the air from here will go through here, right? We had a similar circuit in our carburetor known as idling circuit, right? This is similar to an idling circuit, but in case of idling circuit, see, we could not control the amount of air which was going to the engine, right? We couldn't actually control it. But in this case, using an ECU, we can control how much air is going to the intake manifold for idling requirements, because the throttle valve is completely closed. So this is how your idle speed control system works. Idle speed control system takes input from the sensors and it ensures that the amount of air going to the intake manifold and to the cylinders is sufficient to keep the engine running, right? So this is what idle speed control system is. This is the video that I found really very good. It explains how the idle speed control system works. I request you to watch this. Okay, you can pause it and put these things. It is pretty easy. 77P36-E0H88. Okay, I'm sorry I can click it, but this was a very good video that I found for idle speed control system. They have explained it very well. Okay, and the last thing which is in your syllabus, the last system which is in your syllabus is the air management system. See, air management system by itself is a big system, right? Air management system is by itself controlling a large number of processes. What all is it controlling? It is controlling the amount of intake air coming into the cylinders. It is controlling the filtering of the intake air. See what happens. See over here, this is your intake air. Imagine there are filters of some sort over here. These filters will trap the dust particles. After a certain amount of time, these dust particles will start blocking the flow of air. And due to that, what will happen? Sufficient amount of air is not able to reach the engine intake manifold, right? So from time to time, these filters have to be either cleaned out or these filters have to be replaced. So this is informed to the driver on the dashboard directly. How is it done? What they do is they use a pressure sensor over here. They use a pressure sensor before the filter and they use a pressure sensor after the filter. If there is a lot of pressure drop across this, what does that mean? That some large amount of air is being trapped here only. If there is a large amount of pressure drop between these two sensors, it means that large amount of air is being trapped, and that means that it is time to clear this filter. So that is how this system works. Another thing is the flow to supercharger. See, whenever you are using a supercharger on your engine, you have to determine how much amount of air should go to the supercharger, right? At what speed should the air be turning? Especially if you are using a turbocharger. Okay, turbocharger is a type of supercharger. If you are using a turbocharger, then you have to determine how much amount of exhaust gases is going to the supercharger, right? If you are sending a large amount of gases to the turbocharger, a large amount of power will be produced. If you are sending less amount of exhaust gases to the turbocharger, less amount of power will be produced. So that is basically why we have to control the amount of air going to the turbocharger. Then there is exhaust gas recirculation. You can control the production of NOx by controlling the amount of exhaust gases that are recirculated back into the fresh charge, right? So for that also you can use electronic control system. And the main thing that ECU is generally used for is controlling the exhaust emissions. As I told you during the explanation of lambda sensor, it is necessary that the exhaust gases have sufficient amount of oxygen so that the catalytic converter can do its job, right? So how can we control the amount of oxygen in the exhaust gases? By using this exhaust emission system, right? So these are the different air management systems that we will be studying. Okay, to perform all these functions, such a large number of sensors are required. Okay, all these sensors are required for doing the air management system. We will take a look at some of these systems, not all. First of all, I will explain to you what exhaust gas recirculation system is. Okay, so basically exhaust gas recirculation system. See, how does exhaust gas recirculation system work? Okay, just a minute. Okay. So from here your fresh charge is coming into the engine. Okay, imagine from here fresh charge is coming into your cylinder. Sorry, a cylinder. This is your cylinder. This is your piston right now. These are your exhaust gases which are going out. Right. This is your exhaust port. Exhaust gas is going out. This is intake port. Intake air coming in. In your exhaust gas, what we do, we create this, all exhaust gases are going there. But what we do, we create a small space over here. Okay, we create a small valve over here. A valve is placed over here. There is a valve placed over here, and this goes back to your intake manifold. Okay, this is a valve over here whose position can be controlled, and this goes back to your intake manifold over here. Okay, so when we want no exhaust gas recirculation, we want that the intake air should come in, combust, and all the exhaust gases should go out. When the engine is cold, no NOx is going to be produced, so no EGR is required. So at that time this valve is completely closed, right? But imagine now that we need exhaust gas recirculation. So if we need exhaust gas recirculation, what are we going to do? We are going to open the valve slightly. When we open the valve slightly, what is going to happen? Some amount of exhaust gases are going to go through here back to the intake manifold, right? Some amount of exhaust gases. So the fresh charge coming into the engine will be diluted, and because of this the NOx production will be reduced, and a large amount of exhaust gases will go directly to the exhaust. But what if the amount of NOx production is too high? If the engine temperature is too high, what do we do? Well, it is simple. We open this valve even further. We open this valve even further. If we open this valve completely, maximum amount of exhaust gases will go back into the intake manifold, and thus the charge will be extremely diluted, and only some amount of exhaust gases will go through outwards. So in this way, who is going to control how much of this valve to open? How are we going to decide how much of this valve to open under what operating conditions? That is done by the air management system ECU. That is done by the air management ECU. It takes input from several different sensors. Now what will be the sensors that will be used? Engine coolant temperature sensor, engine speed sensor, exhaust oxygen gas sensor, manifold air sensor, manifold air pressure sensor, manifold air flow sensor, intake air temperature sensor, and many other sensors will be used to do this kind of a thing. These all sensors will collect data and send it to the ECU. ECU, based on the data collected by these sensors and the program written inside it, will control that valve. The valve which I was drawing over here, that is known as the EGR valve. Okay, so this is how they will use it to control the NOx production. Another way of another important air management system is what example is the control of the intake air in SI engines. We have seen in the old engines, how did we control the amount of air coming into the engine? We used the ECU, right? We used the carburetor. In the carburetor, we had a throttle valve. Based on the accelerator pedal position, the throttle valve used to open and close, right? And the suitable amount of air used to come into the engine. But see, carburetor has so many problems. As the engine speed goes on increasing, the air-fuel mixture goes on becoming rich and rich, right? So to prevent that from happening, we can use an ECU. What will an ECU do? ECU will take in inputs from various sensors such as what? Manifold air pressure sensor, intake air temperature sensor, engine speed sensor, throttle position sensor, and many others. Based on inputs from all these sensors, the ECU will send a signal to a stepper motor. Okay, see over here, just I will take 1 second. See over here, imagine this is your throttle. Okay, so you can put a stepper motor over here. What the stepper motor does, stepper motor will control how much this throttle opens and closes. Okay, by controlling the opening and closing of this throttle valve, we can accurately control the amount of air coming into the engine. And by controlling the amount of air coming into the engine, we can control the type of combustion that is taking place inside the engine. Right? So that is how an air management system works for controlling the intake air into the SI engine. So what are the sensors that will be used? Intake manifold pressure sensor, intake mass airflow sensor. Whenever there is mass airflow sensor, there is also a intake air temperature sensor. There will be accelerator pedal position sensor also. If he suddenly accelerates, the stepper motor should open completely, right? The valve should open completely. Therefore, an accelerator pedal position sensor will also be necessary. And what will be the actuator? The actuator will only be the stepper motor, right? So by doing this, we can control the air fuel mixture, and by controlling air fuel mixture, we can control the quality of combustion, and by controlling the quality of combustion, we can control the amount of power produced inside the engine. So these are some examples of air management systems. You can also look at using this, you can also imagine what will be happening in the flow of supercharger. Right? I explained to you how filtering of air works. Over here there is a filter, there is a pressure sensor before the filter and after the filter. Depending upon the pressure drop, a signal is sent to the user. Or else if it is a self-regenerating filter, then some amount of fuel will be dumped on it and it will start cleaning itself. Or it can be an electrically heated filter. Okay, so there are several options. How will a supercharger work? In supercharger also there will be same as EGR. There will be a valve which will control the amount of exhaust gases going to the supercharger. If we want no amount of air to go to the supercharger, this valve will be completely closed. If we want a little power from the supercharger, this valve will be slightly open. And if we want a large amount of power from the supercharger, this will be completely open. Right? So even in this case, what will be the sensors that will be required? There will be an accelerator pedal sensor required, intake manifold air temperature and pressure sensor required, mass airflow sensor required. It will be required to know what is the current speed of the turbocharger also. So there will be an RPM sensor of turbocharger also that will measure what is the current RPM of the turbocharger. There will be an intake, most important function will be intake manifold pressure sensor. It will measure what is the amount of pressure that is being developed. Also there should be an exhaust gas temperature and exhaust gas oxygen sensor to measure the quality of exhaust so as to determine how much amount of coolant intercooling should take place. Remember, from supercharger there is intercooling in turbocharger and supercharger. So what is the amount of cooling required for the exhaust gases to be cooled down? All these things will be done by the sensors. They will send all this data to ECU and ECU will correspondingly control the valve opening of your turbocharger port. Okay, so this is how air management system works. Basically these systems work similarly. They take input from sensors. Whenever you are given a system, you have to remember what are the different types of sensors and what is their function in the system and what is the final actuator that is being actuated. Okay, so similar to this, you can also look at the other systems which are present in automobiles. They are not in your syllabus, but it is always good to know all these information. Okay, thank you.